This is the second part of the healthcare technology maintenance management. In this part, we'll talk about the maintenance management generally, then we'll talk about the expenditures in the maintenance management specifically. The rest of the points will be covered in the last part. In the general talk about the maintenance management, we'll talk about the maintenance planning, the elements and the activities in the maintenance management. Now we'll start with the talk about the maintenance planning. Maintenance is considered as a key part of the life cycle of the medical equipment management. Maintenance planning must take into consideration hospital resources, clinical needs, and a variety of maintenance cover strategies. An important point in the maintenance planning that it's essential prior to purchase that the requirement terms and conditions should be included in the purchase agreement to support the device cost effectively. Thus, the cost of the spare parts, the cost for the maintenance labor hour, and other points should be considered during the signing of the purchase agreement. Also, another point is the flexibility of having access to manufacturer service resources and other options. This will help hospitals to make the most cost-effective decisions on maintenance. Because if we have only a service contract, the maintenance costs will be high. The maintenance management should include the following elements. Firstly, establishing a maintenance program, then determining the device maintenance requirements such as the schedule, procedure, replacement parts, testing equipment, and so on. Then administrating the safety and performance testing as well as inspections and preventive maintenance. Corrective maintenance or repairs is another element in the maintenance management. Finally, the last point will be, or the last element will be the maintenance service contracts. The activities or the maintenance activities can be separated into two groups, direct activities and indirect activities. The direct activities will include the corrective maintenance or repairs, schedule or preventive maintenance, quality assurance testing for safety and performance, calibration, and cleaning. The indirect activities will include the user supports of devices such as telemetry battery replacement, upgrades, installation in the case of the transfer of the device from one location into another, the overhauls and refurbishing, and finally, sometimes the user education and the training is considered as a part of maintenance duties. If this is done due to the reason behind this is to reduce the failures, user errors, and device damage. Now we'll talk about the expenditures and the maintenance management. As we know that the most expensive devices are found in the imaging, the reason because the maintenance expenditures depend upon the device type and its complexity and cost. As we can see in this figure, that the maintenance cost for the medical devices in the imaging, the annual maintenance cost will be around 49% of the total maintenance cost for the hospital. Another point to consider in the expenditures is that to consider the maintenance cost during the medical device life cycle. Because sometimes the initial cost, which will be the capital cost or the purchase cost for the device, will be smaller than the cost of the total cost if we consider during the over the life of this equipment. We will take an example, the nuclear medicine system. The initial cost or the capital cost will be around $400,000, whereas if we consider that the service contract for such device will be around 12%, then the cost will be around $48,000. If we consider this during the life of this equipment, which approximately will be around 10 years, then the total maintenance cost for the nuclear medicine system will be around $480,000, which is a little bit higher than in the initial cost. A small analogy can explain this, which is the iceberg. If we consider the tip and the mass under the water, the tip, which will be considered in our case the initial cost of the nuclear medicine, will be smaller than the life cycle cost for this device. If we consider, as we said before, the total maintenance cost during the life of this device. Also, if we consider other elements such as the employees' salaries and benefits of the radiology technologist, if we consider also the consumables and the cost of the facilities. Thus, we should consider, in addition to the initial cost, the total maintenance cost of this device, and this should be included in the purchase agreement. For example, this is a first totally body PET and CT scan. So this is a hybrid radiology technology. We have the integration between the PET and the CT scanner. This device was approved in 2019 by FDA. Thus, we should consider, in addition to the initial cost, the cost of the maintenance during the life of this device. This also is the same. As we can see, we have a lot of electronic boards and components. We should also consider the labor cost for such technology. Thus, as we said, we should consider we should make an analysis for the complete cost, the initial cost and the running cost of the device. Another point which is important, in addition to consider the total cost, to consider the cost of the service ratio annually. I mean by that, the annual service cost should be divided by the purchase cost and multiplied by 100. This is considered as a performance indicator for any clinical engineering department or healthcare technology department. For example, in USA, the target will be less than 5%. In other countries, maybe this number little bit more or less. So this is very important, which is to consider the cost of the service ratio. If we see in this diagram, which was in 1997 survey, we can see that the cost of the service ratio for the imaging medical devices will be the most higher one. So if by comparison to the other medical devices, which are around 6%. Another point to consider in the expenditures in the maintenance management is the fast response and downtime. Downtime here means the lost income. To demonstrate this point, we'll take 3 examples. The first example will be about the cost for the downtime in the CT scanner, for CT scanner. The second example will be for MRI machine, and the last one will be for the clinical laboratory devices. We will analyze the daily loss in case of the downtime for the 3 devices. In the case of the CT, we consider the cost for the scan cost can range from 700 for a basic scan to 3,500 for a procedure, which involves the use of contrast and multiple views. So if we consider we have 25 scans per day, so the daily loss will be ranged from 17,500 to 87,500. If we consider the case of the MRI with $2,000 charge for each patient, if we consider that we have a daily load of 20 patients, then the daily loss will be around $40,000. In case of the laboratory or clinical laboratory, a lab test is about $60. If we consider that we have around 4,000 tests per day, then the loss will be around $240,000. So the downtime means a lost income, and this should be minimized to in order to avoid the loss to the hospital. So the fast response is very essential to avoid this downtime, especially if we are talking about the essential technologies. From now on, we will have a tech spot in each topic. This tech spot is aimed to discuss a recent technology or trend. The tech spot in this topic will be about the Spectral CT Scanner. We have here in this slide a photo for the dual energy Spectral CT Scanner, which is manufactured by Newsoft, as we can see here. What is a Spectral CT? A Spectral CT is a CT scanner which has a detection for multi-energy levels by comparison to the conventional CT scanner, which is a single energy level detection. We will have two types of spectral CT to make comparison between them. The first one will be the Newsoft. The model will be NewVis Prime, and we will have a short video about this. We'll see the properties, the specification for this spectral CT. The first specification is the time, the scanning time. The second specification will be unlimited tube heat capacity, which is very important. Micro carving technology is used. The second point will be the detector, concerning the detector, error cube detector. As we can see, we have a switching of the kV. We have 80 kV and 140 kV in order to have a spectral emission. And this we see the different energy levels, and we have how they select the best one of them. So these are the features of this spectral CT. Now we'll see the second spectral CT scanner, which also is a dual energy. This one is manufactured by Philips. As we can see here, some photos for this spectral CT. Now we'll see in the next slide a short video for this spectral CT, and after that I will make a small comparison between these two models, and also I will talk about what is the importance of this spectral CT scanner by conventional to the single photon CT scanner. First, I want to mention before to continue to watching this video that the technology between Philips here and the new soft is completely different. In the previous one, in order to have the dual energy, we have the switching between the kV. First, sometimes we use 90 kV, sometimes we use 140 kV. Whereas in the case of this model for the Philips, they used the same tube without switching between the KVs. Only the difference will be in the detector itself. I will stop here. As we can see, we have three different types of a spectral CT scanner technology. The first type is a detector based. This means that the only change by comparison to the conventional CT is made based on the detector. The second type, to having a spectral imaging, we use KV switching as the one used by the new soft above in the previous video, and the last one is the one which used dual source and dual detectors. We have two X-ray tubes and two detectors, so either we have one X-ray tube and one detector, and we make switching between the KV. Sometimes we have like 90 kV, another time we'll have 140 kV, or we'll have two X-ray tubes. One will be for 140 kV and another one will be for 90 kV. The best solution will be the base detector, which will have one detector, and the main difference will be in the detector itself, which allows us to have a spectral CT. So this is the comparison between the different spectral CT scanner. So what is the main difference between why we need the spectral CT scanner? What is the difference between the spectral CT scanner and the conventional CT scanner? Usually the modalities in the imaging department or radiology department can be separated based on either anatomical or physiological. The anatomical usually have a high resolution images, whereas the physiological modalities having a lower resolution image. However, the benefits of the physiological one, it gives us an information about the physiology. If we consider the case of the conventional CT scanner, which is also known as a single photon energy, single energy level CT scanner, this is as considered as anatomical. We have only anatomical information about the patient case. Whereas in the case of the spectral CT, we have two information. We have information about the anatomy and we have also information about physiology. So we're having a high resolution anatomical images with physiological information. This is the importance of the spectral CT scanner, which will be replace the conventional CT scanners. And thank you.